We want to factor and solve the given quadratic equations. Notice in both cases we have a trinomial in the form of ax squared plus bx plus c equals 0 when a is not equal to 1 and it's not a common factor. We've actually covered three methods for factoring these types of trinomials. We talked about the trial and error method, bottoms up method, as well as the grouping method. In this video we'll review how to factor these using the trial and error method. So for our first example, since there are no common factors among these terms, if this does factor, it will factor into two binomial factors. And we know the first terms of the binomial factors must come from the factors of 5x squared. And since 5 is prime, it has to be a 5x and an x. Next, we know the second positions must come from the factors of positive 7, so that the sum of the inner product and outer product is equal to positive 36x. Again, luckily 7 is prime, so we only have to consider two factors of 7, one in itself. Again, notice how we want the sum of these two products to equal 36. So if we put a positive 7 here, notice how that would give us 35x. And then if we put the plus 1 here, notice how the inner product is positive 1x. And 35x plus 1x does equal 36x, which means this is now factored correctly. And because this product is equal to 0, the first factor of 5x plus 1 must equal 0, or the second factor of x plus 7 must equal 0. Now to find our solutions, we'll solve these two equations for x. So here we'll subtract 1 on both sides. So we have 5x equals negative 1, divide both sides by 5. So we have x equals negative 1/5, or here we need to subtract 7 on both sides. So we have x equals negative 7. These would be our two solutions to the given quadratic equation. Now let's try another one. Here we have 6x squared minus x minus 12. And again, there are no common factors among these terms, so if this does factor, it will factor into two binomial factors, where again the first terms must come from the factors of 6x squared, so it could be 6x and x or 3x and 2x. Again, using the trial and error method, we're not really sure. Let's go ahead and try 3x and 2x. And the second terms must come from the factors of negative 12. So there are quite a few factors to try. We could use negative 1 times 12, negative 12 times 1, negative 2 times 6, negative 6 times 2, negative 3 times 4, or negative 4 times 3. But the key is we want the sum of the inner product and outer product to be equal to negative 1x. So again, using the trial and error method, we're just going to place these factors into our binomial factors and check to see which ones will work. But there are a couple things that we can keep in mind to help us. These binomial factors cannot have any common factors since the original trinomial didn't have any common factors. So we wouldn't put a multiple of 2 here or a multiple of 3 here. So if we try putting plus 3 here, we would have to use a minus 4 here. Again, notice how these binomial factors don't have any common factors. And now let's check the sum of the inner and outer product. Our inner product is negative 8x. The outer product is positive 9x. Well, this sum would be positive 1x, and we want negative 1x. But that's an easy fix. We can use a positive 4 here and a negative 3 here, which would change the sign of these two terms, giving us a sum of negative 1. So we'll change this to plus, and we'll change this to minus. And again, now the inner product is 8x. The outer product is negative 9x, which would have a sum of negative 1x, which is our middle term. So we now know this is factored correctly. So now we can solve the equation. Since this product is equal to 0, the factor of 3x plus 4 must equal 0, or the factor of 2x minus 3 must equal 0. And now we'll solve for x. First step here is to subtract 4 on both sides. So we have 3x equals negative 4, divide by 3. We have x equals negative 4 thirds, Or, here we would add 3 to both sides. This would be 2x equals positive 3, and divide by 2. Our second solution is x equals 3/2. Okay, I hope you found this helpful.